Hello, good morning, everyone. So we're going to have math on irrational numbers. I hope you managed to understand and uh, 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 go through some questions on rational numbers, the things that we did last time. Right. So let's go straight into our topic for today. So that is irrational numbers. Now, I'm going to take you back to the definition that we gave on irrational numbers. All right, on rational numbers. Remember, I said that irrational number. Just a recap. Okay, we said that irrational number. I'm going to write that in green. Irrational number, right, is a number that was first definition is a number that has that can be written in the form a over b, okay, that can be written in the form a over b, where a and b are integers, right? B is not equal to 0, and and a over b is in its, okay, let me do this, and a and b have no common factor, other than 1, right? That is one of the definitions that we looked at, right? And this is very important. Number two, the other definition that we said when we looked at rational numbers, we said that a rational number is a number that has a repeating and non-terminating, okay? That has a repeating and non-terminating decimal, okay, and non-terminating decimal. Number three, we also said that it's a number that has a terminating decimal, okay, a terminating decimal. So those are the definitions that we looked at when we looked at what um, when we looked at rational number. So we said that a rational number is a number that can be written in the form a over b, okay, where a and b are integers and b is not equal to 0, and a and b have no common factor other than 1. And then we also said that it's a number that has a repeating and non-terminating what? Decimal. For example, we gave an example of a number such as 0.333333, okay? 0.3333 and so on, okay? So such a number is referred to as what? As a rational number, okay? And then we also say that it's a number that has a terminating decimal. For example, if we just write 0.5, okay, or 0.61, right, or 0.587, right? So all those, as long as it's terminating, the decimal is ending somewhere, it has an end, then we can say that such a number is what? Is a rational number, right? So now, uh, in the same way, all right, in the same way, we are going to define rational numbers, right? Rational numbers. So in other words, we know that rational numbers are the exact opposite of irrational numbers, okay? So when we say irrational numbers, we're going to say that an irrational number, okay, I'm going to rewrite all that. An irrational number right? An irrational number is a number that cannot, okay, that cannot be written in that form. You get the point? So an irrational number is a number that that cannot be written in the form a over b, okay? But all this continues where a and b are integers, b is not equal to 0, and so on. And a and b have no common factor other than what? Other than 1. So we basically get the exact opposite, right? Then we say that it's a number. Here we're saying that it's a number that has a repeating and non-terminating what? Decimal. Okay. So we're simply going to say that it's a number that has a non-repeating and non-terminating. So this part is going to remain just like that. Okay. That has a non-repeating. Okay. Non-repeating, okay, and non-terminating what? Decimal. Okay, non-repeating and non-terminating decimal. Now, that means that even definition number 2, number 3 has been swallowed. Now, let me give an example of that. Okay, so if we say non-repeating and non-terminating decimal, it means that we're going to have a number like this. Let's say 0.427853 6178 and so on and so forth. So you can see that those numbers are not repeating in any order. They are just coming up randomly. The decimals are coming up just randomly like that. You get the point? Unlike in the case of rational numbers where we would have a decimal which is repeating itself. Okay, so a decimal is repeating itself just like that, or maybe you can have 61616161 and so on. So you can see that in that case, in the case of the irrational number, those decimals are not repeating themselves, okay, in any order. So it's non-repeating, the decimal is non-repeating, and it's what? Non-terminating. It's just coming up again and again, right? So that's what it means when you say non-repeating and non-terminating. In the case of rational numbers, we say that it's repeating, the number is repeating, but it's not terminating. Okay, so that's the difference between rational numbers and irrational numbers. Now, other examples of irrational numbers that we have that we can look at, we can have numbers such as uh, let's say root of 2, root of 3, all right, even root of 5, even pi, okay. I know you guys from your grade 8 to 12, you would say that pi is actually equal to 22 over 7, but that's not true. That's a lie, okay. That's not true. It's just an approximate value. You get the point? It's just an approximate value. It's not, because we're saying that an irrational number is a number that can not be written in the form a over b. Okay, it's a number that cannot be written in the form what? A over b. So this pi cannot actually be written in the form a over b. So that value 22 over 7 that you used to look at, that you used to use, is just an approximate value. Even when we say pi is equal to 3.1, 3.42, is it something like that? Okay, that is also just an approximate value, right? It's just an approximate value. It's just rounded off to three significant figures or three decimal places. Otherwise, the pi itself, if you get the calculator, right? If you get your calculator, you'll find that pi is actually no, it's a number that goes something like 3.141592654, and it continues. Okay, it continues like that. So you can see that it's the numbers; those values are coming up randomly, not in any specific order, and they will not terminate. They will just be coming up and up and up, just like that. Okay. That's how it is, right? So that's the definition of what is called an irrational number. So an irrational number is a number that cannot be written in the form a over b, okay, where a and b are integers, then b is not equal to 0, and a and b have no common factor other than what? Other than 1. Okay. Then number 2 definition is that a rational number is a number that has a non-repeating and non-terminating what? Decimal. Okay. A non-terminating decimal. Right. So that's what we have on definition. So here we go straight into examples, right? We go straight into examples. Probably we're going to look at 2 or 3 examples, and then that's basically what we have on rational numbers. There's nothing much on rational numbers. Other than this, than just definition, we look at examples, how to prove that a particular number is an irrational number. That's all that we have on irrational numbers. We just have to prove that a particular number is an irrational number, right? So let's go ahead and look at such an example. So you say example 1. So you say prove that root of 2 is irrational. Okay. So we prove that root of 2 is what? Is irrational. We want to prove that root of 2 is not a rational number. Well, if you get your calculator, and probably, of course, like I said, you don't use calculators in this mathematics. However, if you get your calculator and try to find the value of root of 2, you're going to find that it's like 1.4142, 13562, and so on. So obviously, by looking at the value, obviously you can see that root of 2 is not a rational number, right? You can see that, isn't it? So, but we want to prove that it's not a rational without using a calculator, without getting the calculator and getting the value of root of 2 and so on. We have to prove that. Okay. So how do we go about it? Now, we use the definitions that we gave. The first definition, remember we said that a rational number is a number that cannot be written in the form a over b. Okay, it cannot be written in the form a over b, where a and b are integers, right? Now, my friends, here we use a method called contradiction. We prove by what? By contradiction. Now, when you say contradiction, it means that you have something else, and then you, at the end, you get something else that are opposing. You have one concept, and then at the end, you get another concept that are the exact opposite of each other. Okay? Or you have one idea, and then at the end, you come up with another idea which is opposing the first idea that you had. Okay? So in this case, when we are proving that a particular number is an irrational number, we first assume that that number is a rational number. We know quite well that that particular number is not a rational number. We know that it's an irrational number, but we want to assume that it's a rational number. Okay. Now, if it's a rational number, it means that, remember we said that a rational number is a number that can be written in the form a over b, where a and b have no common factor other than what? Other than 1. Okay, so in this case, we are going to say that we assume that this number root of 2 is a rational number such that it then can be written in the form a over b. You get the point. Are we together? Are we okay? Is it okay so far? So the first thing that we do when proving that root of 2 or any number is irrational, the first thing that we do is to assume that that number is a rational number. And if it is a rational number, by assumption, then it can be written in the form a over b, where a and b are integers, and those two numbers a and b should not have any common factor other than 1. Okay, so that is the first thing that we do. Now, this the way you go about this, you just write, okay? It's like you're writing an essay. Really, that's basically how it is. There's little to do with calculations, okay? There's little to do with calculations. Okay, so let's go ahead and write that. So here we say we prove. Since my markers are becoming faint, we prove that root of 2 is irrational by contradiction. Someone may be asking, so even an exam you write that? Yes, you write just like that. Okay, you write just like that. We prove that root of 2 is irrational by contradiction. Okay, then we say, assuming root of 2 is rational, okay, is rational, then we're saying that this root of 2 can be written in the form a over b, right? A over b, let's call this as equation 1, right? Then root of 2 can be written in the form a over b, where a and b are integers, right? Then b is not equal to 0, and a and b, right? A and b have no common factor, okay? Have no common factor other than what? 1, okay? Then a and b, where a and b are integers, b is not equal to 0, and a and b have no common factor other than what? Other than 1. Okay, so that's the first thing that you do. That is your first step. You make that assumption, right? The second step that you're going to do is to make a subject of the formula in equation 1. Okay, so we make a subject of what? The formula in equation 1. That is the second step, right? So let's go ahead and do that. Now, how do we make a subject of the formula? Okay, so we say squaring both sides of equation 1, right? Remember, equation 1 was root of 2 is equal to a over b. So we square both sides, okay? So basically because we want to make a subject of what? The formula. So these are the little calculations that are there when you're dealing with such equation, okay? So this is going to be 2 is equal to, this is a squared divided by what? B squared, okay? And then we go ahead and cross multiply there. We're going to have a squared is equal to 2b squared, okay? Now this little equation that we've come up with is very, very important, okay? Very important equation. Now I want to show you something that is interesting, okay? Something that is interesting. Let's say, for example, let's say we have what? Okay, whenever you multiply any real number, whenever you multiply any integer by 2, right? When you multiply any integer by 2, the number that you get is what? Is actually an even number, okay? So if you say 2n, where n is any integer, so if this n is representing, let's say 3, then what you're going to have is what? 6, right? If you say 2 multiplied by 4, the number you get is 8. And this is an integer. 2 by 5 is equal to what? 10. All these are what? Are even numbers. So in other words, what we are saying is that whenever you multiply any number, okay, by 2, you multiply any number by 2, any integer by 2, what you are getting is what? is an even number. Are we together? So when you multiply any integer by 2, the value you get is an even number. So what does that mean? What it means is that this number that we have here, this 2b squared, okay? 2b squared, we are multiplying this number b squared by 2. Let's say, for example, 2 multiplied by 3 squared. Let's say our b is 3, right? Let's put it like that. Then it means that this is going to be 2 multiplied by 9, which is equal to what? 18. Okay. If we say, for example, 2 by 5 squared, this is going to be 2 by 25, which is going to be equal to 50. And we know that 50 is what? Is an even number. So in other words, whenever you multiply whatever integer by 2, the answer you're getting is an even number. Okay. Now, so we have concluded that this side, what we have on the right hand side of this equation is what? Is an even number, not so. Are we okay? Are we together? Is it fine? Hello? Anyone there to respond? Are we okay that what we have on the right hand side is an even number? Okay. Chris, are we okay? Do we agree that it's an even number? I can't get you, Chris. Okay. Tina, hello Tina, are we okay? All right, perfect. Okay, so whenever I need you guys to respond, please be quick to respond so that we move on quickly. Okay, so we have agreed that what we have on the right hand side is an even number. Now, there's something also that we need to agree, right? We need to agree on something as well, that uh, the square, okay, the square of any even number is also an even number, right? The square of an even number is an even number, so is the square root of an even number also an even number. For example, if I say 6 squared, okay, 6 squared is going to give us what? 36, okay? Vice versa, the other way around, if we say that square root of 36 is going to give us a 6, isn't it? If we say 10 squared, this is going to give us what? 100, okay? The other way around is true. The square root of 100 is going to give us 10, okay? If we say, let's say 12 squared, this is going to give us what? Let me use black, all right? If we say 12 squared is equal to 144, right? So is the square root of 144 going to give us what? 12. So again, we should agree that the square of an even number is also an even number, and the square root of an even number is also an even number. Okay, so when you have, as long as I mean, it's a proper, it's a square number. Okay, it's a proper square number as long as it matches with that. So what we're saying is that when you calculate, when you try to find the square root of any even number, the answer you're going to get is also an even number. Or if you find the square of an even number, the answer you get is also an even number. Do we agree that? Now, remember, what we've already agreed is that what is on the right hand side here, what is on the right hand side is an even number. We have agreed that, right? So meaning that what we have on the left hand side is also what? An even number. Because if we say that x is equal to 10, right? Then it means that this x is actually 10, isn't it? That's what it means. So if we're saying that a squared is equal to 2b squared, then these two are equal, right? And so if what we have on the right hand side is an even number, even what we have on the left hand side is also what? An even number. Right. What we have on the right hand side is on the left hand side is equally an even number. Okay, that's what it means. So here we just basically need to conclude. All right, because we've concluded that what we have on the right hand side is an even number, then a squared is also an even number, right? A squared is an even number. Now we've said that if we find the square root of an even number, what we get is an even number. So if we get the square root of a squared, which is going to be what? A. The square root of a is a, meaning that even a is an even number. So imagine if we were saying that, if we had said that a squared, all right, if we had said that a squared is equal to, let's say, 100, okay, if we had said something like this, right? If we had a squared is equal to 100, then it means that if we get the square root, a was going to be equal to what? 10. So this means that our a is also what? An even number. That's what I really needed to emphasize. I wanted to emphasize on this fact. Now, the other thing that I want you guys to take note is that it's not always that you're going to be dealing with 2. Okay? It's not always that you're going to be dealing with 2, and so it's not always that you're going to be saying even number, right? If you're dealing with, let's say, square root of 3, right? The general way of saying that, you would say a multiple of such a number. For example, instead of saying even number, we would say a multiple of what? 2. Okay, because we know that even numbers are basically or simply multiples of what? Of 2. So if we are dealing with root of 3, then we'll deal with multiples of 3. If we are dealing with 4, obviously root of 4 is a rational number. Yeah, so we can't deal with root of 4. If we're dealing with root of 5, then we're going to be saying a multiple of 5. All right, if we're dealing with the root of 6, then we're going to be dealing with what? Multiples of 6. So I don't want you to be so glued to what we're saying, because we're using even number, so you can still use let's say multiple of 2. Okay, that is more general, right? So let's make a conclusion there. So I needed you guys to understand these concepts, because a lot of students, most of the times, they just tend to memorize how to go about proving that a particular number is irrational. But I want you guys to understand and have it in mind, right? So we're saying that since 2b squared is an even number, okay, now I want you to take note that we can also say that since root of 2b squared is a multiple of 2, okay, that means the same thing. An even number or saying a multiple of 2, that is one and the same thing, meaning that if you are dealing with any other number, you'd rather use multiple of whatever number you are dealing with, right? So take note of that. So since root of 2b squared is an even number, then a squared is an even number, and a is also an even number, right? So that's what we have concluded from what I was explaining. We have concluded that root of 2b squared is an even number, and because of that, a squared is equal to an even number, and so is a, because the square root of an even number is also what? An even number. Okay, it's also an even number. Now, since we are saying that A is an even number, then A can be written in this form. Okay, let's look at this. Okay, we're saying that since A is an even number, then it can be written. It can be written in the form what? A equal to 2k, all right? Where k is a natural number, right? It can be written in the form 2k, where k is what? Is a natural number, right? Can be written in that form 2k, where k is what? Is a natural number. That is how you represent all even numbers. That's how you represent them. Okay. Like I said at the beginning, you can say 2n or whatever number, whatever letter you can use, right? Where this n is a natural number. So if you put 1 here, it's going to be 2 by 1, which is 2, right? If you put a 2 there, it's going to be 2 by 2, which is 4. If you put 3, it's going to be 2 by 3, which is 6. So in the end, you're going to have 2, 4, 6, 8, 10, 12, and so on and so forth. All those that you're getting are what? Are even numbers. So in the same way, because we are saying that this A, we have concluded here that A is an even number, then it can be written in this form, A equal to 2k, all right? Now, we then substitute this, let's call that other equation that we had as equation 2, all right? So we're going to say, then A squared equal to 2b squared becomes, okay? So that equation that we had becomes what? So where there is, where we have A, we're going to put 2k squared, 2k, okay? So this is going to be, 2k squared equal to what? 2b squared, right? And then what are we going to have this side? This is going to be 4k squared equal to 2b squared, right? And then we can see that we can divide both sides by 2, such that what we're going to have is b squared equal to what? Equal to 2k squared. Now, the same concept that we had has come here, right? So you can see that what we have on the right-hand side is an even number, right? Just like we had, remember we had a squared equal to 2b squared, isn't it? So it's a similar case. We concluded that this was an even number. So even in this case, this is an even number. And because of that, it means that even what we have on the left-hand side is equally an even number. So if we get the square root of b squared, we're going to get a b, which is also what? An even number. Okay, so let's make that conclusion. We say, since 2k squared is an even number, then b squared is an even number, and b is also an even number. Okay, is an even number. Now, you guys look at this. Look at what is interesting about this, right? So we have concluded that A is an even number, so it can be written in the form 2k, isn't it? And then B is also an even number, so it can be written, let's say, in the form 2n, right? I've just used two different letters. So we're saying that A and B, we have concluded, the first conclusion we had was that A is an even number. Again, here we're saying that B is an even number, meaning that these two numbers can be written like that, okay? So let's even forget about the A and the B. So it's like we have those two numbers, 2k and what? and 2n, isn't it? So we can see that there is a common factor between those. If we say if we say a over b, then this is going to be 2k divided by 2n, isn't it? And those two numbers a and b are then having a common factor. We can see that there's a common factor here. Okay, a 2 there is a common factor, isn't it? So if two numbers are even numbers, it means that they have a common factor of what? Of 2. Or even numbers have a common factor of what? Of 2. Now remember our definition. In the first place, we said that we are assuming that this number is is a rational number which can be written in the form a over b, where a and b should not have any common factor other than 1. But in this case, we have found that these two numbers, a and b, are having this common factor, which is what? Which is 2. Okay. And this is what is going to give us a contradiction. Remember, I said that when we are saying contradiction, it means that in the first place, you have this one idea, and then you come up with another idea which is opposing the idea you had at first. So the idea or the assumption we had at first was that this number is a rational number being written in the form a over b, and a and b have no common factor. Okay, there's no other common factor other than 1. But after working out, we can see that there is this common factor which is 2, right? So this is what is posing the contradiction. All right, so let's write that. We're saying that since both a and b are even numbers, then they have a common factor. They have a common factor of 2. Okay. This contradicts the earlier statement that a and b should not have any common factor other than 1. Okay, hence by this contradiction, root of 2 is irrational. Okay, hence by contradiction, root of 2 is what? Is irrational. Okay, so you guys, this is how you go about these questions. This is how you prove that root of 2 is an irrational number, right? Now I'm going to give you an assignment because of time. Okay, I want you to prove that root of 3, okay, root of 3 is irrational, and root of 5, okay, just these two. Okay, now remember I told you that here we are dealing with 2, so that's why we are using the word even. So in this case, you're going to be using statement like multiple of 3, multiple of 3. Instead of saying even, you're going to be saying multiple of 3 and so on, right? And then even here, you're going to be using multiple of 5, just like that, right? So I want you to try and work out that, and then you can send me your solutions. Then I'm going to look at them and give you feedback, right? So I'm going to look at a few more questions, probably these same ones that I've given you as assignment. The next time we are going to have math, right? So that's how you go about irrational numbers. Hope you've enjoyed. I hope you've gotten it. See you in the next video.